Zoom, where are you? Okay, I'm having technical difficulties finding the Zoom window to share the link, but you can search XReality. Yeah, that's it. Try to search it. XReality um, Patreon. We're doing an experiment right now. So if you want to join me in the Zoom session, you can get the link in the future by going to our Patreon. So it's Patreon XReality Pro. And in the future, we'll be posting, I guess, a link to these sessions so you can be in here with me asking questions. For now, if you want to watch it for free, it's on LinkedIn Live. So I guess that's the all the administrative stuff. Okay, so I plan to be doing these Skillshare sessions every Thursday from 5 to 6 at this time. And my goal is to be able to build a multiplayer game that is, silence my phone, running in a website. So like I said, I'm a web developer, and we're going to create a game that, let's say you're on your desktop computer, or you're on mobile, that's an iPhone, or you're on your headset. So if somebody's wearing this headset here, you'll be able to all see the same things. So all of you would have maybe not exactly the same experience, but if on somebody's screen there was a cube, and we'll create some very simple avatars. In fact, it'll be so simple, it'll just be like a cube for a head, maybe cube for your hands. And then so if one person moved right or left, it would be synchronized. You'd all be able to see that. So we're going to be working up toward that over the next couple of weeks. And there's a couple of building blocks and tools that we need. So in the front end, we're going to be using Babylon.js. Keep pressing the button. And in the back end, the server, I've chosen to use Phoenix. Did I spell that right? Elixir. And I'll kind of go through that in a bit. But first, let's talk about what is WebXR. Odd. Clear the whole thing. Interesting. Okay. So WebXR, it has the word web in it, so it runs in your browser. XR, if you know nothing about this sort of industry, it stands for extended reality. Let me move this Zoom window away. So extended reality includes virtual reality. And usually that means that you're wearing something over your face. So you're wearing that headset. Here's your headset, and it's occluding your vision. It's blocking your eyes. So you're wearing this headset, and it'll bring in a whole new virtual reality, new walls, new skies, mountains, all of that stuff. It also includes AR, which stands for augmented reality. And usually this meant that you had a device like an iPhone or an iPad with, okay, so if this is the back, you have like a front-facing camera on the other side. And so if you were looking at a table, you would see that table being projected into the camera or the video screen here. And so then you could place an object here. So maybe on here, you could have a dinosaur here. And so you'd be able to move your iPad around left and right and look at different objects in the room. So this is augmenting your reality by superimposing something on that tabletop. Now with the Quest 3, there's something called mixed reality, which is that it actually has these really good cameras on the outside of it. I think they're like this. And they actually now can bring in your real environment, but it's still it's projecting it like video. So your true vision is obscured, but it brought that into the virtual reality world. So it's kind of like an intersection in between these two almost, because you're in your virtual reality, but you're superimposing something on top of uh, your real environment. And mixed reality allows you to do stuff like not only can you place the dinosaur on top of the table, but it can like tell with a depth map where the table is, and you can actually have this dinosaur slightly occluded, like behind the table. So this is sort of the definition of what XR is. XR is just an umbrella term, meaning all kinds of reality, all kinds of extended reality. Now, if you Google what WebXR is, you'll probably end up on a documentation page by Mozilla that says, yeah, we could Google it right now. What is WebXR? And you'll end up on a documentation like this. So it's a set of standards, specs, API that allows you to create an immersive experience to project onto a headset like this, or augmented reality. So WebXR, right? VR and AR. And the good news is you don't have to read all of this, because this is maybe at a lower level API. See, here are some of the terms like XR anchor, XR session, the pose. We largely do not need to know that, because Babylon.js is going to take care of that for us. So WebXR, WebXR are a set of standards and APIs on top of the browser's APIs, game controllers, WebGL. So WebGL is allowing you to write shader programs for your browser. So and you may have heard of a term called OpenXR. So OpenXR is just the big brother of WebXR. It's nearly the same thing, except OpenXR is to OpenGL, sort of, as WebXR is to WebGL. So these are graphical languages, again, a set of standards and APIs that allow you to color your screen with pixels. So if this is your monitor, and if we divide the monitor up into pixels, right, the GL, or the way you program OpenGL, WebGL, is you write some low-level programming languages. So it's sort of like C, but it breaks down into a pixel shader and a fragment shader. And you basically write a program to be able to hand it like a definition, some object, some numbers that represent, a box in 3D, for example, right? And so the pixel shader would be able to set the color of the pixels, and the fragment shader comes in and it kind of like does some math, and it says, oh, between here and here, the normals of where the box are facing certain directions, so I know how to shade this thing. I know how to fill in the pixels between the corners of the box, something like that. And the good news is, unless you're writing shaders, which there are, Babylon.js does provide a node material editor. So if you're used to that, so we can use that. We largely do not need to learn OpenGL or even WebGL. You can, it provides you a way to write that program in a string, and you can pass it to Babylon.js in order to render it for you. But this tends to be a lower level API, and we're going to operate at a higher level API. So we'll be doing things like, oh, here's a box, here's a sphere, and this is the material I want to give it, and it will render it correctly. Whereas if you're in OpenGL, you have to solve a lot of things yourself, like the object data and the order in which things should be drawn, and the transparency, and how is the view projection matrix. So it's very math heavy, and we won't be spending much time in there. We won't be spending much time in WebXR either. So the title of Introduction to WebXR is really just for branding. We're going to be learning Babylon.js, which wraps both of these things for us very conveniently. Can I just... Let me do a new whiteboard. Maybe that'll clear it. Oh, I retained something. Anyway, okay. Some questions that I get asked sometimes are why use Babylon.js or WebXR? Why not Unity? And why not A-Frame? They've heard of A-Frame before, or Three.js. And then for server side, well, we'll answer this question first. So maybe first, why not Unity? So I would say if you're a Unity developer, you probably should stick to Unity because you're used to it. You can get things done. You're productive with it, and it's got great resources, right? People have built a lot of things for it. So if you're comfortable with Unity, Unity actually has different exports. So Unity, if you don't know, is an integrated development environment that gives you like a viewport, and it has like a scene, and you can drag things in it, and then you can add like scripts to it, and then you can export to different targets. So you could say, I want to export the code that I've written in C# to desktop, or I want to export it maybe to mobile, or I want to export it to a head-mounted display like the Quest. So it's sort of this really nice thing. You can write once and then export. I mean, there are some exceptions, like you need to check some configuration because not all features are supported everywhere. So the head-mounted displays are usually are underpowered compared to their desktop equivalents. So it's more similar to developing for mobile when you're developing for the headsets. But the issue that I have with it is that the target is going to be compiled, and I believe it would be something like C, maybe to C++, or maybe C, or maybe to like a WebAssembly or something. Or they may use something like mscriptum, which is a cross compiler which will take C code and then spit out WebAssembly code. I'm actually not sure how they do this, but it's difficult to debug. So if you have a JavaScript bug or some bug in a WebAssembly, you now don't have a easy way to debug that in the browser because it wasn't written in the browser. You developed it here in Unity and you shipped it across the wire. So when you have a target, it's going to give you a folder with some files. You take those files and then you put it on your server. So if it works, then everything's fine. But if there's issues and you're developing along the way, you don't really get a web developer's experience. And that's sort of what developing natively or web natively in some of these other choices will give you. So I'm not saying one is better than the other. I'm saying they're the different experiences with pros and cons. So judge what kind of game that you're trying to produce. What are your constraints and timelines if you need to learn something new, and judge for yourself. So that's why I didn't choose Unity, because I'm a web developer and I also like using the browser's APIs. And one of the things that's nice about the browser is it comes with built-in controls. Like if you're on a desktop, you can turn on the webcam or ask access for the webcam. You can get to their microphone. You can play sounds. if you're on mobile, you can get the gyroscope, the sensors on it for orientation. So there's all kinds of cool things that you can get access to with the browser's APIs that maybe are not possible or maybe more difficult using Unity. So if we've decided not to use Unity, our choices are JavaScript libraries, because that is the language of the web. So ugh, I need a faster way to clear the whiteboard. Okay. So when I first started, I was looking for some JavaScript libraries. There's A-Frame, there's Three.js, which is probably the biggest and oldest, most mature of, I wouldn't say most mature. It's the probably the most well known. And hence A-Frame was built on Three.js. There's Play Canvas, and maybe a couple others. So Play Canvas I didn't entertain because it didn't have a no strings attached open source license. So I think there were some strings attached. So I just looked at these. A-Frame was super easy to get started, and they have this WebVR experience. And the way A-Frame works is that you would create some HTML tags that are specific to A-Frame. So they're custom components, and you would say, it looks something like this. It would be a scene, closing tag, a scene. And you would just write that like regular HTML. And in here, their getting started guide is so easy. At the top of the header, you would have some script tag with the source coming from some CDN, um, whatever, CDN, A-Frame, something, da 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 da. So just by including that, you get to use these things. And then you would say a box. I think that's what it is. And then you have a default box. It is so easy. And then you could say like I don't know, rectangle or sphere or something probably. And then you look over and then you render the scene, and then right away, oh, there's a box in your scene. So it's so simple to get started. So I started with this, and then very quickly I outgrew this. And so there weren't other components for other things that I needed. So if I wanted to add some behaviors, the way that it adds behaviors is it forces you into this model. So you have to write the HTML, and you have to write these components, the properties on these HTMLs that they call components. So if you wanted to do something like a spin component, or like an oscillating component, so something that makes this bounce up and down, you would have to go define this thing, and then that thing ultimately results in you writing a class that you could put in. So you have to write that in Three.js. So um, I thought that this was an unnecessary abstraction. Like who are we writing this for? This makes a lot of sense if you want to say, oh, developing in 3D VR is as easy as HTML, and here are some building blocks. If it was a mature building block thing with all of the components you would ever need, then that would work. But my experience is that when you added additional script tags for other components that would allow you to put more things here, um, they would break because of the different versions of Three.js. So Three.js did not broke compatibility all the time. And so that sort of broke the promise of A-Frame having these different composable components that you could just bring in and it would just work very smoothly. It wasn't smooth at all. I had trouble understanding it. I couldn't get different components and different A-Frame libraries to work together. And Three.js was just different versions of Three.js just broke the code, broke examples all the time. And I haven't had that experience with Babylon. So Babylon declares that it's always backwards compatible. It's the only one that claims that. Oh no, I did it again. Oh, okay. You make a mark, it doesn't register as an object. So that's how we ended with Babylon.js. It's future and backward compatible, or not future. Well, it's backward compatible. And the way you learn is you go to the playground, for example. So I'm going to introduce the Babylon ecosystem a little bit, and then I'm going to show you how to install Babylon. And if there's times, we'll answer or ask any questions. So how are we doing on time, Tom? Okay, about halfway. Okay. So the Babylon ecosystem. So if you go to Babylonjs and just search it and come up to their website. And probably the first place I would start is their documentation. So their documentation actually has like a quick getting started guide and then can go in depth. So they have this, your journey starts here. So you can read all of this, how to add Babylon.js to your project. And so this is a very good starting guide. And what I really like about their guides is that they have working code in the playground. So if you were to search something like WebXR, they have a good search. And here's an introduction to WebXR. And you see these things on the right? These are links to the playground. So if we click over to this one, for example, this will open up a new window. So playground.babylon.js, and it has this snippet code. So you can, if you save this, it will produce a new snippet code like 32324, for example. You can you can create as many examples, as many snippets as you want, and you grab that URL for whatever changes you've made, and you can post it to their forum, which is often the case of how we get answers to our questions. You would go and make an example with code, and maybe something just needs to be tweaked. Like you don't know how to do this one thing. So you put up all of your work self-contained in the playground, except for the little piece that doesn't work, or including the piece that doesn't work. Then you go to the forum and you say, this is what I've tried. Here's a link to the playground. And then often, because you've done so much work and there's a starting point for answering that question, people come in and just fix it. They'll just, a couple of people will say, well, how about this? Or how about this? And then they'll just save it into a new snippet, post it back in the forum. So I've thought that that was an incredible idea, and it's a very valuable resource in order to learn these things. One thing that I suggest, because we're going to be going into VR games, right? By the way, I'm only going to be covering VR. I'm not going to be covering mixed reality or augmented reality because I don't think not that I know that, as far as I know, Babylon.js doesn't support like the pass-through stuff yet. Maybe that's coming. If you're dead set on doing that, you can go the Unity path, but I don't think that's here yet. But you can install a web extension to simulate the headset. So for example, this is a playground that is enabled for WebVR. I'm not putting on the headset, but there's this button that will start the immersive experience. And this button would only appear if your headset was VR capable. And right now we're fooling the browser that the headset is capable because we have that extension installed. So if I click this, it should jump me into the experience. Make something happen. Oh, construct point event. Maybe this one was a bad example. Let's try this one. That one. Okay, this one went into the web experience. You would open up your console, and with the web extension installed, this is actually produced by Quest. It allows you, see, we have our controller showing up. It allows you to click and drag in here to move your head forward and backward, move your controllers up and down, and then you can control your controllers over here with the toggle stick, the joystick, the pressing of the buttons. You see it's kind of doing that. So this is one way to test. And so you would go to your extension, your Chrome extension store, just search WebXR. And I think there's two extensions. Pick one. This is the Quest one. I haven't fully played with this, so I think it might have some features for that I don't know about, but that's pretty valuable for testing as well. So coming back to resources that you can use. So there's the playground, there's the forum to ask questions. There's also the YouTube video channel. So that's you can just go to YouTube and search Babylon, and they produce some pretty nice tutorials and videos. So that's another learning resource there. Let's go to essentially talk about how you would install it. So it's very similar to the way we install A-Frame. The way it works is you have your browser on this side. Browser. And typically it makes a request to a server. All right, that's your browser. This is the server. And you request some path. So you're going to host this someplace. It could be like index HTML or whatever path that you decide for it. Then this is going to ship some response back. If it's loading a web page, it'll give you back a bunch of stuff. Among it is a body, and in there is the text of HTML, all this kind of stuff. And so in the header portion, there's a header. You're going to have a script tag, maybe multiple script tags. Among them is the core library of Babylon.js. So it provides a CDN to Babylon.js, and then maybe other libraries for materials, for physics. Those are all separate script tags that would be in here. And then you would have to construct your engine. So once you have Babylon there, let's see if we can do another whiteboard. Make a whiteboard, yes. Ah, that's easier. Okay. Amongst the HTML tags, there's one tag in particular, which is the canvas tag. Ooh, pink came out red. So the canvas is a special element that allows you to draw. And Babylon.js is going to take the name of the canvas. So usually this would be identified by some ID, like my canvas or something. And then this would be used to bootstrap an engine. So in Babylon.js, first thing you need to construct is an engine. And you pass in the ID or the canvas into the engine. And then from the engine, our main building block is a scene. So a scene is going to contain everything in the scene. So it's going to contain the camera. It's going to contain your meshes, your objects. It's going to contain your materials. All of this stuff is hanging off the scene. So you're going to create a scene, and then you won't be able to see anything unless you have a camera. So you have to make at least a camera. And then typically you need some objects in the scene, and these are called meshes. Also, you probably want to see it, otherwise you'll be in complete darkness. So you also need at least a light. So this is kind of the stuff that I think A-Frame was trying to abstract you away from. Like you didn't really need to do anything. You just said box, and you could see a pretty decent looking scene. But this only has to be done once. And so I also heard or read on a forum, and I agree with this, that A-Frame makes things simpler, which were already simple, and it makes things more difficult, things that are difficult more difficult. So I kind of like that assessment. Da, 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 da. And that's it. And then outside of the engine, you would say like start looping. And because that's how your browser works anywhere. There's a certain refresh rate on your browser already. The engine just ties into that, and it takes all of these things, it ships them to WebGL. So it writes some pixel shader, fragment shader business for you, ships it over here, and then this thing takes all of this and it rasterizes it. It produces all the colors on the pixels for you, including all the light calculations and all of that kind of stuff. And depending on how many meshes you have, this shipment to WebGL is relatively expensive compared to how fast the GPU is. The GPU is very fast, but shipping it across the wire is slow, and this is known as a draw call. So there's some limitation that the more of this you send over there, you'll start impacting your frame rate. So there's some limitation. But if you sort of make your game sort of low poly and not ship that many things, try to combine things, there's a way to optimize your scene so that you're minimizing draw calls. And these on OpenGL, this would be drawing on your screen on the canvas. You're drawing to the canvas, and this is rendered in your browser. So this doesn't even need to be full screen. We're doing WebXR, which will take VR, which will take over the screen when you go into the immersive experience. But there's nothing stopping you from just having like a web page with certain sections of it rendering a 3D scene. So that's useful for like a preview of a person that you can like click and drag and it rotates this and you can have another spot. These could be just different scenes, just different Babylon engines just running in your browser. And your regular scroll works. You scroll up and down, and this is very useful for like product previews and that kind of stuff. So Babylon's a very versatile engine for the web. Now, of course, we are going to be taking over the whole screen because we're going to be doing WebXR. Okay, so let's pick apart one playground. So this will be our assignment today. Let's go into the playground and see how it's set up and how you would install it. So if you just go to playground.babylon.js, they've actually abstracted some of that engine stuff. So the only function that they expose here on the code side is just the scene. So here they're creating a new scene from an engine, and engine isn't defined up here. So they're hiding it from us to try to keep it simple. So scene equals new Babylon scene. By the way, there's two classic ways to install. Where is it? Where's my whiteboard? I lost it. Did I close it? Closed it. What's it called? Whiteboard? I forgot to mention is that if you're what I call classic web development is that you use the CDN and you import these script tags. Script source, Babylon, blah, blah.
May I ask you what's a CDN?
Oh, it's just a content delivery network, CDN. And so there is a network of, let's say this is the bad drawing of the United States. Let's say that there's these servers distributed globally across the world. Then the CDN is delivering content closer to you by shipping copies of it across the world so that when you use the CDN, it's finding that source code, in our case, Babylon, shipping it to you from the closest location. So it's a highly reliable network, content distribution network.
Thank you.
Yep. So in the classic sense of developing, you're writing your HTML by hand and you're putting this script in, and then what the Babylon.js script does is it injects into the window object a global variable called Babylon, all caps. So when you create new objects, you would say new Babylon, and this might be, I don't know, mesh builder. I want to create a cube or something like that. We'll look up how it is. So you have this available to you. And so using this approach, using the CDN approach, they expose Babylon available to all of your code. It's global. But the new, I guess, modern style of web development is you use NPM packages. So if you're developing on your local machine, you would do npm, it's a command line, you would do node package manager, and you would do install Babylon core. And there's a couple of flavors. There's one that starts with this @ symbol, Babylon, like core or whatever. And then there's the version that doesn't start with it. And the difference is that these are ES 5 or 6 modules, and then these are something else. So the only difference is that this can maybe produce smaller code because it supports tree shaking, which means that if you would use, like if you're using TypeScript, and we'll get to this in later lessons, and you do import something, rather than saying import everything from Babylon.js, which would import a whole bunch of library stuff that maybe you're not even using, you could say import just the class name that you want, like just camera from Babylon core cameras, and it would just import that camera that you need. And so when I develop in my project code, I'm doing it the new way. So I do not have this global namespace available to me. I'm just importing what I need, and it should result in smaller bundles. But at the end of the day, when you're doing it this way, and I'm using TypeScript, which Babylon is written in, and it's really good for when you're using VS Code, the IntelliSense, when you hover over things, it'll say, oh, this is of type this, and I'm expecting this kind of variable, and it's a number or whatever. Using JavaScript, you don't get that. So we use TypeScript. We need to transpile it to JavaScript, and I'm using a bundler called ESBuild for that. And so this ultimately is ingested the same way, except this is going to result in multiple Babylon.js files and put this on the namespace. When you use a bundler, it takes all of your JavaScript and all of your dependencies, and it will wrap it into it's called an immediately invoked function expression, immediately invoked function expression. And all that is it defines a function and then immediately invokes it so that no one from the outside can access anything from the inside. There's no global Babylon on the window object, and it prevents people from messing with your code or calling your code from like opening up the JavaScript console. I've made a mess with this diagram, but hopefully you're following what I'm saying. Okay, so with the time left, let's go and pick apart and just play with the playground. I want to demonstrate how it's really easy to just call regular JavaScripty code. So we have in this scene, this is the default playground, Babylonjs. And I said we have the camera set up, and this is a free camera, which means that when they attach controls into it, you can freely move it. So I can turn right, I can turn left, I can look up and look down just by dragging the mouse. I can press the arrow keys, so I can go travel forward, travel backward. And then the playground gives me the ability to do some inspection. So if you click this thing on the right, you can check your camera. These are the things in my scene. So I have a camera, and you can look at your position, for example. So if I move this backward, you see how these numbers are changing a bit. They change rotation. They're being updated here. Now none of what you do here, even though you can like select and maybe move some things. So I think, what is it? This, I think there is a way to click Oh, I'm on the camera. Sorry, I need to click on the sphere. Yeah, you can scale it, you can move it. Keep in mind, this is just changing it here in this preview. It isn't making contributions to your code here. So even if you save this, this is really just for you to preview and play with it. But if you want the sphere to be saved here, you would have to go and look at its position here. So here we're inspecting the sphere. Look at the position. So here the Y is at 6. So if we wanted it to stay there, we could modify the sphere position Y to 6. Let me show you how the sphere was created.
I think the right-hand side panel was being cut. So yeah, the
Oh, it's being
right-hand side. Yeah, being cut a little
cut off
bit.
on your screen? Oh,
Mhm.
okay. Am I not sharing my full screen?
Oh, not really full screen. Yeah,
Oh,
part of it. Yeah.
oh, okay. Can you see the mouse up to this point?
Still, but no, not this point.
Oh,
Yeah.
okay. So you're cut off over there. Oh,
Mm.
okay. Oh, I'll try to fix that for next time. Okay, so let me close the inspector. Um, Babylon.js has a pretty good mesh builder. So this mesh builder allows you to create different kinds of objects. So here's the light that we're talking about. This is just creating a hemispheric light, which is just sort of over everything. I think you pick the direction. So this is up. So I guess you point the direction where the light is. And so it's coming down, right? The light is coming down. So maybe this direction is you're pointing at where the light is. I'm not sure. And you can specify the light intensity. So what I really like about learning with the playground is you just go and mess with stuff, right? So you see the light intensity. So if you turn this down, you would expect, and you press play, okay, it's darker now. Right? You put it to 1, it's bright. And you just play with stuff here. So here's a sphere. Under Mesh Builder, you can create columns, your typical primitive objects. So we can create another object. We can create a box. So we say var, prefer to use let actually box Babylon. And see, even in the web, they have sort of like this IntelliSense. It's not quite, but it's hinting at what functions you can call on the Babylon object. So you can say mesh builder, and just hit tab to complete. And then you can see, oh, what's on the mesh builder? Well, there's a create box tab. Open up, and then here, there's more hints here. So it's saying, okay, the first parameter is a name of the box. Okay, I can just say my box. And then there's a list of parameters here. So they're all optional. So the question mark here means you don't have to provide anything. So at this point, I could just remove this comma and see if it creates a box. So if I just did this, because everything else was optional, right? So if you look over here, it took 3 arguments. The next option is an optional. We don't have to provide it if it's optional. And it takes a scene, which is also optional. So I guess it infers that it's the current scene. So without those things, let's see if it creates a box. So you can barely see it underneath here. We can move it by accessing its attributes. So if we get the box, we can see that it has a position property, and this position has X, Y, and Z. So X is your left, right, Y is your up, down, and Z is your forward and backward. So from here, if I want to move it forward and maybe move it to the left, so Z, I can't remember if it's positive or negative. Let's try positive. So let's put maybe 2 meters. So all the numbers here are defined in meters. Okay, so that seemed like it moved forward. So -2. So here it is. And maybe let's move it up. So position Y, let's move it higher. Let's make this maybe 5 meters. Where did it go? Oh, too high. Let's maybe 2 meters. Okay, so now it's in front of the sphere. And to the left, position X -1. Okay. And if we wanted to animate this, Babylon provides these callbacks. So one very useful one is the scene on before render observable. So an observable is something that's going to watch something. It's going to say, I'm gonna pay attention to everything every time this thing happens, and then you'll be able to add your callback or your code that's going to run every time this thing happens. So remember, there's that render loop, and right now, because I'm on a Mac that has some kind of GPU, it's running at 120 frames or so. So this would be called that many times per second. So I'm going to say add. I'm going to add a new callback, and I'm going to use this anonymous function expression. So whatever code I call in here will be called on every frame. And so if I would like to, let's say, oscillate this up and down, I'll just tie into that Y position. So box position Y equals something. And the something, I think we can get oscillation using math sign, right? So when you put a number into sign, it just goes between 1 and, is it 1 and 0 or 1 and -1? So we can put an ever increasing number in here, and as it executes frame over frame, it'll just oscillate between these two numbers. So we can say, let's just call it count. We need to define count, so I'm putting count out here. So let's just do let count equals 0. And in here I can do count plus plus, which is just lexically bound. So this count is initialized to 0, and this count refers to this one, but it keeps increasing. Let's see what that does. Okay, so that's wigging out up and down super fast. So if we wanted to slow that down, this number is actually an integer, so maybe that's too big. Let's put a tiny amount on it, so 0, 0, 1. Okay, maybe a little bit faster than that. Okay. So here's an example of, we just used one of the built-in libraries of JavaScript. JavaScript comes with this math library with sine and cosine and arctan and all kinds of stuff. And we've hooked into the life cycle of the scene. The scene is going to do something on every frame. And in fact, that's how you get animations, is that you're just changing the state. You're moving things a little bit here. You're changing the position or rotation. And you're just saying, hey, call my code on every frame. And on every frame, it's sending the current state of the world, writing that in that draw call, sending that to the GPU and say, here's the new position of all this stuff, render all the pixels. And this is happening 120 times per second. And that's basically what it's doing there. Okay, let's add another cube. We can use standard for loops, right? So we can make a bunch of these things. So here we created a box. Let's say, how do you make a for, whoops. I make a for loop for, let I equal 0 to, let's make 10, I plus plus. You can put that box creation code in there. So just copy this, put it in here. So we're just saying, make a bunch of boxes. We don't want to give them the same name. We can give a different name. So we can just say if you use this backtick, it's evaluating the I in there. So you can say box, and then if you'd use this $ mustache, it'll be box 0, box 1, all the way to box 9 for different names. We want to spread them out a little bit, because if we just did this, and let me pause. I'm going to comment this out for a moment. Let me comment this out. This will actually create us 10 boxes. But because they're all on top of each other, you can only see one box. And let's comment out the sphere. Let's play. So now we just have that box. So how do we spread them out? Well, the only thing that changes in every iteration is the I. So we can use that incrementing number. I is going to go from 0 to 9 to affect our position. So we can say box position X equal I. So on every new box that's being created, the first one will be created at position 0, the next one would be created at position 1, and so forth. So that kind of gives you a list of boxes, and I made 10 here. Because they're butted up right next to each other, and I think the default for a box is just 1 meter by 1 meter by 1 meter, they're perfectly stacked that way. If you wanted to alternate their height as well, then you could say box position in the Y direction is also I, and that should create sort of the stair step effect, right? So now we have boxes here. So, and this is standard JavaScript, right? So now if we wanted to oscillate all of them, how would we do that? Well, we can grab them. We need a way to grab them and iterate through them and then do this position sign thing on them, right? Before we had one box, and so we had a variable available to us. We said box position here. Now this box actually is defined within these curly braces. So it's not available to us outside because I use let. So it's scoped within these curly braces. I can't get to that box. And even if I could get to that box, like which box are you talking about? So Babylon has a way of querying all the objects on it. So we could do something like Babylon, I think it's get meshes or find. I'm trying to find it. I'm trying to remember what it is. Oh, maybe it's scene. It's on the scene, right? Scene dot get meshes. Get mesh by name, so you can find the meshes. You can get active meshes. So that would give you a list of all the meshes, actually, including the ground, though. We don't want the ground. And if they had a sphere. So although it has methods, or we could get mesh by tag. And so you could give all of these a kind of a label, like a tag, like a string to say, these are all boxes. And then you could get all meshes by tags and it'll allow you to grab them. But there's just an easier way, which I prefer, is just to save it into an array. So you can have a new data structure, say let boxes, which is an empty list, an empty array. And then for every box that you make, just stick it into that container. So boxes push box. And now boxes has a bunch of boxes in there. It will have every box that you created saved in here. So then now we can, in our observable, which is going to run on every frame, let's go through the boxes. So boxes, and another way of iterating instead of the for loop, which we can also do the for loop, is just the for each. And this will give you the box. So if I write a function in here, box, and I throw this in here. So for every box inside that array, I'm going to change its position to be math sign. And I think they might all go up and down at the same time. Let's see. Nothing happened. Oh, I don't have a count. Right. So when you're doing this, you should probably have the console open to see if there's JavaScript errors. That might be cut off on the screen. Let me move this to a different location. And let's do it. Okay, so they're all moving in unison. It actually overwrote the stair step effect because this count is the same for everyone. So if you wanted to stagger it, you could maybe, instead of absolutely changing it, just like add a difference to it. Let's see. comment that out. Actually, I see that we are just out of time, so that's maybe an exercise for people to do, is just play with the playground, see if you can produce something moving around, try adding some other objects, try loading some GLB files, so files that you maybe created with Blender or other tools. The content that I covered today is probably chapter 1 of a book that I'm writing. So if you're interested, you can go to GitHub, my name, Homan Chou /XR. And I'm writing a book. And chapter 1 was sort of what this book about and who is this book for. And I talked about like A-Frame and Three.js and some of these things that I talked about today. And it's an ongoing project. So I intend to release it open source. So you can go there, read ahead. And so every Thursday, I'm intending to cover maybe not a chapter per session because I'm still sort of sizing them up, but I've written a couple chapters and eventually we'll get to doing voice over WebRTC. We're going to create a game similar to Doom where there's monsters and you can pick up weapons